The purpose of this video is to answer the question, what is infinity? More specifically, what is the thing we call positive infinity in the context of calculus? This is a question that many calculus students ask at one point or another, and it isn't really answered outright in textbooks, so we're going to spend a few minutes here doing so. Let's start. Our context is the real number line, which is where we'll be looking for positive infinity. Where do we think of it being? The idea of positive infinity is simple enough. It should be way off to the right, past all the real numbers. You can look at this picture and it makes pretty good intuitive sense. But where exactly is that arrow pointing? What is positive infinity, and how do we define it? Before we get to what positive infinity is, let's see what it isn't. 10's a pretty big number. Does this express our concept of positive infinity? Well, no, because 100's even bigger. How about 100? Well, 1,000 is bigger still. In fact, whatever positive number we choose, 10 times that number is even larger, so that number couldn't be positive infinity. Our conclusion is that positive infinity is not a number, which is an important first step. More specifically, whatever we mean by positive infinity, it should be larger than any positive number. Trying to nail down positive infinity at one spot on the real line is impossible, as we've just seen. This is because positive infinity is an ideal location on the real line, in the sense that its exact location is unattainable. But this doesn't mean that we can't see it. To figure out where on the real line positive infinity lives, let's carefully read this statement. Positive infinity is larger than any positive number. Well, 1's a positive number, so wherever positive infinity lives, it must be among the real numbers greater than 1, which are shown here. None of these numbers are infinite, but some are certainly closer to positive infinity than others. The numbers farther to the right are more like positive infinity, and those to the left are less like positive infinity. If we toss out some of the numbers that are less like positive infinity, we'll get a better picture. So let's push our left end up to 10. Now this still isn't positive infinity, but I think we can agree that our new picture is more like positive infinity than our first one. Zooming out, we find ourselves in exactly the same situation. If we push the left end up to, say, 100, we'll get a picture that's even more like positive infinity. As we push the left end forever rightward, we get a better and better picture of positive infinity. As an ideal location on the real line, this is the best we can ever do. In fact, this moving picture is the definition of positive infinity. An interval extending rightward, whose left end pushes ever farther to the right forever. This motion is essential to getting the concept of infinity right, and this is where paper and books have failed us. Motion is what allows positive infinity to be, eventually, larger than any positive number. This definition of positive infinity isn't something you're likely to see in a calculus textbook, but it's completely rigorous, as we'll see later in this series of videos. Positive infinity is just one of a set of objects that we call near numbers. They're not individual numbers, nor fixed sets of numbers, but objects in the real line that squeeze forever nearer to some location. A few examples of basic near numbers are infinite near numbers, such as positive infinity, which we just saw, and negative infinity. Finite near numbers, which squeeze towards some point on the real line in a specific way, and constant near numbers, which consist of any set of numbers in the real line. These don't actually squeeze at all, but they're useful for discussing things like indeterminacy or the sign of positive infinity. Near numbers provide the proper conceptual framework for building a more complete understanding of every core concept and definition of calculus, from limits and indeterminacy, to the derivative and the integral, and even sequences and series. That's the end of this video. One moving picture really does express exactly what we mean by positive infinity in calculus. If you already know calculus and have doubts about this assertion, please watch our next video to see all this ties into the usual definitions. Please share this video and check our blog, where we'll announce new videos and discuss questions that come in. And don't hesitate to use the contact email below if you have any questions along the way.